10:45, let's get started. And if you were here for Chip Ingram about Know Yourself, well, I'm an astrophysicist. I'm also a theologian, the president of Reasons to Believe. And you might wonder where I am on the Myers-Briggs. I'm an NERD. So that's probably all you need to know about me. Okay, and I'll be speaking twice today, and both talks I'm going to be giving you the very latest on the fine-tuning evidence for the God of the Bible. And there are multiple ways you can engage us. Let's see if we can get this back up here. Thank you, there. So we actually have a 24/7 YouTube channel that you can watch. Most people are engaging us through that means. You can also contact me through texting my name to 31996. And I do have a Facebook and Twitter page where I field people's questions. So if you've got atheist or skeptical friends, feel free to send them our way. And we do have a table out there. And at that table, we're giving away this new DVD, Reconciling Genesis and Science. And the plenary tomorrow afternoon, I'll give you just a little snippet of what you'll find in that DVD. But yeah, if you go to our book table, fill out a card there, they'll give you a free DVD that you can share with your friends. We also offer free chapters of our books. If you go to reasons.org/Ross, you can download a free chapter of the 4th edition of The Creator and the Cosmos, and also you can download a free chapter of Improbable Planet and several of my other planets or other books. But what I'm going to talk about today is the ultimate darts player. And, I don't know how many of you are familiar with the game of darts. This is a game where you throw darts at a dartboard and you try to go from a score of 501 down to 0. But you have to get 501 exactly. And what I really want to talk about is a new dart game where you're actually throwing darts at planet Earth. Now, I'm not a big sports guy, but I grew up in a family in Canada where hockey was a big thing. And one of the interesting things about hockey is that there's one hockey player that dominates all other hockey players. They call him the Great One, Wayne Gretzky. He's actually got more assists than any other player in history has of total points. But he's not the most dominant sports figure in sports. There's another one that dominates to a far greater degree than Wayne Gretzky, and it's this individual here, Phil Taylor. He's won 15 world championships in the game of darts. He's the first person to hit 9 dart finishes in one match. Okay, I remember telling you 501, you got to get down to 0. You have to hit 0 exactly. There's only 2 ways you can do it. You throw 8 darts at triple 20 and 1 dart at triple 7. You can do that in 9 darts. Another way to do it is you hit 6 triple 20s, 3 bullseyes, and 1 triple 17. There's no other way to get it down to 501 with just 9 darts. This guy has done it a total of 22 times, and he's done it publicly 22 times, many more times privately, but 22 times. In fact, in one televised match, he was able to hit 2 501s in one single match. No one has come close. And but there was another dart player who does even better than Phil Taylor. And we're going to talk about the ultimate darts champion. And it's our Creator. You may not know this, but our Creator's been throwing darts throughout all of Earth's history. What he's been doing is he's been very carefully throwing darts at planet Earth. You may know them better as asteroids. Asteroids striking the Earth at just the right size, just the right composition, just the right time, and just the right location. He's done that 3 times in the last 2.5 million years. And if he hadn't thrown these 3 darts exactly at the right time and the right place with asteroids, and these are really big asteroids, all of them are bigger than 1 kilometer in diameter. And typically when you get something that big, it wipes out advanced life. But if it wasn't for these 3 darts, we wouldn't be here today. Human existence and human civilization critically depends on these three darts. Now, there are many more darts that have been thrown at the Earth, all of them crucial for our existence. I'm just going to talk about the latest three. And these are three that have only been discovered in the past few years, some of them just the past few months. And so I'm going to begin with the one that's been known about for over a decade. And this is the asteroid that struck in the South Pacific Ocean. That little red dot there shows you where it struck. And that red dot represents the size of the crater it would have made if it had hit on land. So this is an object more than a mile in diameter that struck in the ocean. It hit at a place where the ocean is 17,000 feet deep. And when it hit, it caused a big splash, as you can imagine. How big of a splash? Well, it sent tidal waves going 1,000 feet high. And how they discovered this particular event is they found evidence for these huge land disturbances all around the Pacific Ocean. In fact, they even found in the Adriatic Sea, that region between Italy and Serbia, Yugoslavia, they found evidence of a 1,000-foot high tidal wave that went up and caused devastation on the region around there. That's how massive this thing was. It hit 2.58 million years ago. Now, that's an interesting date because that's the start of our Ice Age cycle. And I've written the book Improbable Planet, why it's crucial to have an Ice Age cycle if you want to have billions of people living on the Earth at one time. We can't grow food to feed billions of people unless we're living in an Ice Age cycle. But it's this event that was primarily responsible for starting the Ice Age cycle. And the problem is this: we're living in a solar system where the sun is getting brighter and brighter as time goes by. But there's a moment when the sun hits a point where it has maximum luminosity stability. That happens when it's about halfway through its nuclear burning cycle. But that also means that that's a time when the sun's been brighter than it's ever been before in the history of the Earth. And what's interesting is for 90% of Earth's history, there's been no ice on our planet at all. Here the sun is brighter than it's ever been before, and yet we've got ice. We've got an Ice Age cycle. This particular event is a primary responsibility for why we have that. Because what happened was, when it hit that very deep ocean, it sent salt water up into the atmosphere. It actually hit right down to the bottom, 17,000 feet. And so the crust at the bottom of the ocean floor, 17,000 feet below the surface, was broken up and ejected into a cloud of vapor around the Earth. And so you have all this crustal material, the salt, the water, and it formed this vapor which actually blocked out the light of the sun to a significant degree for over 2 years. Basically brought about what we call a nuclear winter equivalent. And this cooled the whole planet down. Cooled it enough that 5 other tectonic events in combination could actually turn our planet from having no ice at all into having this regular Ice Age cycle. But this was the prime igniter. It was this event, for example, that caused ice to be able to develop all over Antarctica. And speaking about Antarctica, Antarctica was attached before this event to South America. And then it broke off from South America. And researchers are still studying the degree to which this asteroid collision was responsible for causing Antarctica, after it broke off from South America, to move down towards the South Pole. But this is what happened. It moved down towards the South Pole. When it got right over the South Pole, the tectonic plates stopped moving. And Antarctica's been there ever since. And so it's sitting in the coldest possible location on planet Earth. You've got this asteroid hitting in such a way to bring about a cooling event, and this is what causes thick ice to form all over Antarctica. Now, ice has the property that it reflects sunlight very efficiently, with about 60% efficiency. And so this actually has a cooling effect on the entire planet. Moreover, there's an ocean current that runs around Antarctica. Notice Antarctica is the most isolated continent on planet Earth. There's open ocean water all the way around. And we call this the area of the Roaring Forties because you've got a powerful ocean current that runs all around Antarctica, a powerful wind that runs all around Antarctica, and this has a cooling effect that together with its location over the South Pole and this asteroid that hit just below the south tip of South America causes it to be covered with all this thick ice. And also generates a cold current running up through the Atlantic, and it goes all the way up into the North Atlantic. This is one event. A second event that happened at the same time is what happened to Greenland. Greenland was situated off of Newfoundland, and its tectonic plate moved towards the North Pole and then began to stop. Same thing as Antarctica. It was in a more low latitude location. This tectonic plate moved it to the north, and when it got there, it stopped moving. But interestingly, it stopped right over a hot plume. If you're not familiar with that, the Hawaiian Islands are an example of a hot plume region where you got hot material coming up from the lower mantle up towards the crust, and when it gets near the crust, it pushes the crust up. And so the state of Hawaii is the fastest growing state in the Union today because it sits over that hot plume. It gets bigger and bigger as a result of that push-up. This is what happened to Greenland. Greenland, when it was off of Newfoundland, had an average elevation of 500 feet above sea level. When it moved over the hot plume, its average elevation went up to 8,000 feet. And with every 1,000 feet, you get a temperature drop of 3.5 degrees. And so this is what caused Greenland to be covered over with a thick sheet of ice. And remember, ice reflects sunlight with 60% efficiently. So this had a dramatic cooling effect on the entire planet. Simultaneous with what happened to Greenland and Antarctica is what happened to the continents in the Northern Hemisphere. You probably remember the story of Pangaea, how there was a supercontinent that broke up to the 7 continents we have today. That's been happening throughout Earth's history, the supercontinent cycle, where continents will come together, split apart, and come together. This is the first time where a supercontinent split apart and most of the continents went into the Northern Hemisphere. But also went into the Northern Hemisphere in such a way you get almost a perfect enclosure of the Arctic Ocean. So in this particular map, you're looking down on the North Pole. That little red dot represents the North Pole. And you can see how North America and Asia, Europe, Greenland, and notice those little islands off of Norway and Russia work to enclose the Arctic Sea with land masses. And land masses are always colder in the wintertime than open ocean water. And it was this event that caused the Arctic ice cap to form. Before this happened, there was no Arctic ice cap. Now, open Arctic ocean water reflects sunlight with only 6% efficiency. When the Arctic ice cap formed, it was now 60% efficiency. So it's had a dramatic cooling effect on the whole planet. Here you get to zoom in and actually see how those islands and continents enclose over the Arctic Sea. The fourth event, and again, these are all happening simultaneous to one another, is what happened to North and South America, where we got North and South America separated with big ocean. And this causes warm equatorial Pacific Ocean water to come into the Atlantic. And here we got Antarctica pushing cold water up the Atlantic, but now we got warm tropical Pacific Ocean water coming in and blunting the cooling effect. But the moment that the Isthmus of Panama forms, that stops the flow of warm Pacific Ocean water into the Atlantic. And now you get the full cooling effect of that cold water coming up from Antarctica, and this has the effect of cooling all the land masses that adjoin North and South America. But the most dramatic tectonic event of all is what happened to India. The Indian subcontinent was attached to the island of Madagascar. It broke off 70 million years ago and then began to move north. but it moved north at an extremely high velocity. You say 22 centimeters per year doesn't sound very fast, but in geophysics, a really fast tectonic plate movement is 2 centimeters per year. This is 11 times faster. And so when the Indian subcontinent met Asia, there was a terrific crash. The ocean floor between the Indian subcontinent and Asia got buckled up by this collision and formed the Himalayas. The Himalayas have only been here relatively recently. Incidentally, this collision is still taking place. The India today is still moving north into Asia at 5 centimeters per year. And so the Himalayas are getting higher and higher as every year goes by. And the Tibetan Plateau behind it likewise is getting higher and higher with every year that goes by. The average elevation of this 1 million square mile area, we call the Tibetan Plateau, today is at 17,000 feet above sea level. High enough that we actually get what's called a third ice cap forming. We got an ice cap over Antarctica, we got an ice cap over the Arctic Ocean, and a third ice cap is over the Himalayas and the Tibetan Plateau. But what's significant about this third ice cap, it's at low latitude. Such a low latitude that the sunlight that reflects off of it reflects with 4 times the efficiency of sunlight reflecting off of Antarctica or Greenland. So this actually has the biggest cooling effect upon the planet, second only to that asteroid that collided in the South Pacific Ocean. However, these 5 simultaneous tectonic events, combined with the Eltanin impactor, set up this ice age cycle where we go from 10% ice coverage to 20% ice coverage. And you say, we need the melting ice from the last ice age to provide sufficient water to irrigate the great agricultural plains. We also need this ice age cycle because with each ice age cycle, you get a fertilization event where nutrient-rich material off of the high mountains and plateaus gets dumped onto the low agricultural plains. We can grow the food to feed 6 or 7.5 billion people because we got water from the melting ice left over from the last ice age, and we got all this fertilization coming from the movement of these nutrients off the high plateaus and onto the agricultural plains. Also, when the ice leaves from the last ice age, it ignites volcanic eruptions all over the world, which deposits iron-rich dust on all the agricultural plains. But here's the problem. The ice age cycle started 2.58 million years ago, but it was a 41,000-year cycle, which meant that you would get about 3,000 to 4,000 years of a warm interglacial, and you get about 37,000 years of ice covering the planet to 20% coverage. And civilization is only possible, human civilization is only possible in a warm interglacial. But 3,000 to 4,000 years is not enough time to launch global high technology civilization. So God threw a second dart at planet Earth. And this dart hit in the South Pacific, or the South China Sea, in between the Philippines and the nation of Vietnam. And that little red circle you see there, that represents the minimum size of the crater. The blue represents the maximum size. You probably know this area as the disputed Spratly Islands. We got 7 different nations fighting for sovereignty over these tiny islands. But before this asteroid hit, it was a big island. The asteroid basically obliterated this one big island and left only a few tiny islands in its place. But by obliterating this island, it sent up this vast debris of dust into our solar system. And every 100,000 years, we pass through that dust cloud. And this is one of 14 different factors that was responsible for changing our ice age cycle from having a periodicity of 41,000 years into having a periodicity of 100,000 years. So this is what it looked like until 800,000 years ago. where we had this 41,000-year periodicity, which wouldn't permit the existence of human civilization, and then a transition. If you want to see this in detail, this is what it looks like in detail. This is the last 4 ice age cycles. And what you notice here is you get a long period of ice covering our planet to 20% or a little bit more. Then you get a brief episode where the planet warms enough where our kind of civilization is possible. But if you look at the previous ice age cycles, what you notice is you have this long period of ice covering the planet, and then very quickly the temperature goes up to a peak, and then it drops back down. And those previous ice ages are a problem for a civilization. The temperature jumps up to a peak about 2 degrees centigrade above where we are right now, basically melts the polar ice cap. And what happens when you melt the polar ice cap, you now got a lot of water vapor in the atmosphere above Canada and Siberia. And with all that water vapor, it falls as snow. And quickly, you have Canada and Siberia being covered by thousands of feet of ice. And the last ice age that came all the way down to Southern California, covered all of Wisconsin, Minnesota, and all of Ohio was covered as a result of this particular ice. Now, to look at this in detail, here is the temperature profile for the last ice age. So this shows you from about 90,000 years ago to about 17,000 years ago. This is what the global mean temperature was doing. And what you see there is that the global mean temperature was jumping up and down by about 20 degrees Fahrenheit on time scales of just 1 or 2 or 3 centuries. Now, this explains why humans living during the last ice age were not able to launch global civilization. We now have evidence that I document in Improbable Planet that shows us that humans living 15,000 years ago, 20,000 years ago, even 36,000 years ago, were actually engaged in bakery industry. They were planting different grains, they were harvesting the grains, roasting the grains, grinding the grains, and making bakery products. Very sophisticated technology, but it had to be all done on a very small scale because they couldn't count on temperature stability. They would basically plant maybe 15 different crops on 1 or 2 acres, and most of the crops would fail, a few would make it, and they'd try to feed their families and the few that would make it. It wasn't until we had temperature stability that it was possible to scale up and specialize our agriculture. Notice today, we have cornfields that measure hundreds of square miles across. And we can do that. We can grow a huge abundance of corn, wheat, rice, etc. We can do the same thing with our animals, where we can have a ranch where we got thousands of just one kind of animal. That was not possible until we had temperature stability. And that temperature stability did not exist until just the past 9,500 years. And I've written a new book. It'll be coming out in March or April of 2020, explaining how we got this amazing period of great temperature stability. I'm going to give you a little clue of one reason why it happened, and it was thanks to God throwing another dart at the earth of just the right mass, just the right composition, and just the right location, and just the right time. Because what I'm going to do in the next slide is show you a detail of the global mean temperature for the past 17,000 years. And so what you see there in that pink line is basically a typical temperature change. But if you look at those dotted lines, you see that instead of the temperature jumping up quickly to 2 degrees centigrade above where we are right now, it stopped short and experienced a brief cooling phase. That dotted line shows you the temperature, instead of going up, suddenly drops by 15 degrees, stays down at that cold temperature for 1,200 years, and then jumps back up. But that's what we call the Younger Dryas anomaly, and only in the past few months have we discovered the cause of this 1,200-year cooling event. For 30 years, it was a mystery in geophysics as to what caused this dramatic cooling event. Now we know what caused the dramatic cooling event. It was an asteroid that hit in northwest Greenland. So this is a location. That red dot there shows you the size of the crater, but the crater was only discovered a few months ago. Why? Because a crater lies 3,000 feet below the Hiawatha ice field in Greenland. Here basically shows you a close-up of what that looked like. And here you actually got to see the crater that lies below the ice. And it took a NASA aircraft flying over that glacier field with deep penetrating radar to say, wow, there's something strange underneath the ice. And then several geophysicists visited the site and actually saw meltwater coming underneath the ice, and it had the chemical signature of a metal-rich asteroid. This asteroid was literally a little more than a mile across, and it hit 12,800 years ago. And what's interesting about 12,800 years ago is that we have ice melting off of Canada, and that melting of ice left a gigantic glacial lake that we call Lake Agassiz, an enormous lake. And before the asteroid hit, the lake drained into the Gulf of Mexico. The asteroid basically sent up a huge cloud of big rocks and a lot of ice, and they began to fall upon parts of North America. And the net impact was the rocks fell in such a way as to block the exit of water down to the Gulf of Mexico, but it opened up two more channels where cold glacial water could flow up into the Beaufort Sea, there between Alaska and the Yukon, and also out through the Great Lakes into the St. Lawrence. It caused two flows of cold glacial water to come into the North Atlantic, and the convergence of these two flows stopped the Gulf Stream. The Gulf Stream is that warm water that comes up from the tropics of the Atlantic and actually makes it possible for people to live in Norway and Sweden today. But with this flow, it stopped that Gulf Stream and led to a global cooling effect, such that instead of the temperature jumping up to 2 degrees centigrade above where we are now, it stopped short. So this asteroid basically prevented the global mean temperature from getting as high as it was. It also brought about a very brief period of temperature stabilization. We're only talking a few centuries, but what those few centuries did is for the first time enabled humans to begin to scale up and specialize their agriculture. And what that did, it happened at a time, and this again is perfectly timed, because you've got the shift in the tilt of Earth's rotation axis. When it tilts down, the planet warms up. When it tilts up, the planet cools. And it's that tilting that's responsible for that 41,000-year cycle. And so what happened 8,700 years ago is that it reached the maximum tilt up, and now, tilt down, and now it's beginning to tilt up. We should have seen a dramatic cooling over the last 8,700 years as a result of the tilt moving back up. The reason that hasn't happened is there was a brief period of climate stability which enabled humans for the first time to begin to scale up their agriculture. We call it the Neolithic Revolution. It happened beginning about 10,000 years ago, where humans began to have huge farms where they had 10,000 goats or began to grow wheat over square miles. And that actually brought about a warming effect. I mean, for example, you may have heard that people are concerned that we need to get rid of cows because it's causing global warming. Cows emit greenhouse gases, which tends to warm the planet. Thousands of years ago, that was a good thing. The cows that we domesticated, the rice we started to grow, the forests we were cutting down and transforming into pasture lands, all contributed to warming the planet at exactly the same degree that the changing tilt of our rotation axis was cooling the planet. They perfectly canceled one another off. And this has mystified people studying this, saying, how can this be that these natural phenomena are being perfectly balanced by human activity? Okay, I want to get you to think about that, but notice what we see here, that blue line, that shows you the global mean temperature over the past 9,500 years. It turns out that over those 9,500 years, the cooling from natural processes were slightly greater, very slightly greater than the warming from human activity. Basically, over the last 8,700 years, the global mean temperature has declined by 1 degree. Now, it's causing all this controversy over global warming in the last 70 years because of the dramatic expansion of human industrialization. We've warmed the planet by 1 degree. The planet today is the same temperature as it was 8,700 years ago. But it took 8,700 years to cool it by 1 degree. We warmed it by 1 degree in just the last 70 years. But notice how different that is from the norm. That pink stuff you see there, that's the norm of temperature changes. The blue has never happened before in the history of the Earth. And so one reason why I wrote the book Improbable Planet and the new book that's coming out called Weathering Climate Change is to make the point these past 9,500 years is an extraordinary gift given to us by the ultimate darts player. He's been throwing these darts. He's been organizing these 5 simultaneous tectonic events. He's responsible for organizing human activity. Everything has been fine-tuned, not just in terms of the natural phenomena, but in terms of our human activity, to give us this brief period of this exceptional period that's never happened before in the history of the Earth, where for the first time it's now possible that we can grow a large population. Not just the thousands that existed before this event, but up into the millions and the billions, where we now have the temperature stability that enables us to launch global civilization with a technology that we can take the good news of salvation through Jesus Christ to all the people groups of the world, not in millions of years, but in only decades. We're literally within reach. Right now, evangelical Christians have the technology, the financial resources, and the people to fulfill the Great Commission, the command that God gave us at the end of the book of Matthew to take the good news of salvation to all the people groups of the world. It literally can be done in a single decade. But it couldn't have been done unless God had granted us this period of extraordinary climate stability. Now, in my new book that's coming out in March or April, I talk about how this narrow time window of just 9,500 years coincides with over a dozen other very narrow time windows. In the time I got here, I'm only going to share one. And one is, we live in a unique supernova moment. Say, what's a supernova? Well, a supernova is a giant star that ends its life by having a massive explosion where for a period of 7 months, it outshines the light of an entire galaxy. And so this kind of shows you what it's like to go through. There you go. I had this in Keynote. It's much better in Keynote. But this table here shows you the norm. Our Milky Way galaxy gets 3 of these supernovas on average every 100 years. And this shows you the supernova eruptions that took place in human history. And shows you that before the start of this 9,500 years, you've got 4 supernova events that are closer to us than 1,000 light years. Now, that's not so close that it wipes out human civilization or wipes out human beings, but it is close enough to make it impossible for us to launch global civilization. Supernova this close will lower food productivity. It also brings about a health hazard. The cancer rate goes up, but it doesn't wipe out all of humanity. When we had 4 of these events just before the start of the ice, or this 9,500 year period, but this is what we see in the past 9,500 years. Yes, we're still seeing supernova erupt, But notice none of them erupt any closer than 9,000 or 5,000 light years away. If they're more than 5,000 light years away, it has a zero effect on our plant productivity. It has a zero effect on human health. But at no other time in the history of the Earth have we had a moment 10,000 years wide where there hasn't been a single nearby supernova eruption. And my point is, notice that this unique window of supernova activity falls exactly on top of this window where we got extreme climate stability. And if I had time, I could give you about a dozen more simultaneous narrow time windows that all line up. Now, my atheist colleagues will say this is all just a coincidence. Now, they can say that because typically they're so specialized in their scientific research, they're only looking at one of the time windows. I founded Reasons to Believe 33 years ago, basically to take scientists out of academia and give them the freedom to do cross-disciplinary research. And when you do that cross-disciplinary research, you see it's not just one window, we got over a dozen windows. And it's not just one asteroid hitting 800,000 years ago, there's 13 other events that must take place as well in order to shift the periodicity from 41,000 years to 100,000 years. And basically what I want to share with you in this talk and the talk I'll be giving this afternoon on the habitability of planets is that the more comprehensively we study the book of nature and the more we learn about the book of nature, the stronger and stronger case we get for the Christian faith and the complete inerrancy of the message of the Bible. And with that, I'm going to leave the remainder of the time for questions on any subject you want to raise. Please speak loud enough that I can hear your question. I'll try to repeat the question too. We've got a question here. Yes.
Yes, I wanted to ask you if what the people that believe in global warming right now in a major way are trying to change that global warming, are they doing the right things? Do you agree with what they're trying to do to cause that to?
Okay. The question she was asking is, what about these experts, climatologists in global warming? What are they recommending as how we should be responding to what's been happening the past 70 years, and how would I respond? Well, typically, what I do see is that you've got people on both sides of this global warming debate. What has happened in the past couple of years, there's now agreement both on the global warming proponent side and the global warming skeptic side that the warming actually is real. It's because the temperature records are so well established and so globally distributed, and we can see that the causes of the global warming are quite clear. There's still a debate today on what's most responsible for the global warming, but there's no longer a debate on whether or not we're getting global warming. Clearly, global warming is happening. But where you really see a difference is how we should respond to the global warming. And one reason why I'm coming out with this book is to make the point we got to take the politics out of the debate. And what's driving the politics is you got one side of experts and politicians saying this global warming is a crisis and we need to do everything we can to bring the temperature back down to what it was 100 years ago. The other side is saying, yes, but to do that requires such draconian economic sacrifices, there's no way we're going to be able to enforce it. People are going to cheat. And so what I've been recommending in the book I'm coming out, there are ways where we can re-stabilize the climate where we have an economic benefit. So you put more money in people's pockets and actually do the thing that helps the climate and helps all the animals and plants on planet Earth, who's going to vote against it? The reason we got a big debate going on is people are saying, we all have to stop driving cars, we need to shut down all of our factories, you need to get used to a standard of living that's 20% of what you got right now. That's a hard sell. Many people will say, fine, I'm willing to do it, but what are you going to do about the people who say we won't? And basically, they're ignoring a Christian principle. A Christian principle is we're all sinners. We're all selfish. And when governments tell us to do things that counter our sinful nature, you're going to get people that will cheat. you're basically just going to open up a black market. You're not going to help things anyway. And so what we need to do is come up with win-win solutions. And I actually argue this is a principle taught in the book of Job, that God told us we're to manage our planet for the benefit of us and the benefit of all life. I think what bothers me about some of these global warming proponents, they're only thinking about other life, not our life. The Bible says, do what's beneficial for both humanity and all the rest of Earth's life. It's both. It's either or. It's both and, not either or. And so we need to come up with solutions that are actually win-win. And the amazing thing to me is there's a whole bunch of solutions that are relatively straightforward to do that would boost the world's economy and at the same time stabilize the climate. So I'm hoping people actually look at some of those proposals. Yes?
Does the pollution that we create have a big effect on global warming? And I, for one, am just as concerned about pollution as I am about global warming. I mean, it's, within 100 years, at the rate we're going, including this planet, that global warming may be somewhat irrelevant.
Okay, that's a good point that he's raising, namely that when it comes to fulfilling the command that God gave us in Genesis 1 and in Job 37, 38, and 39, that God has put us in charge of the planet to manage its resources for our benefit and the benefit of all life, we need to be looking more broadly than just global warming. I mean, there's all kinds of things that we're facing that are causing our planet to be polluted and causing damage to take place to other life forms on planet Earth. So while we focus on this global warming, we're going to miss the issue. For example, what you'll see in my new book is that there's a lot of focus on carbon dioxide. And yes, we're putting a lot more carbon dioxide into the atmosphere. But for example, the biggest factor in melting ice in Canada and Siberia and the Arctic Sea could quite likely be soot being deposited on that ice. And where does this soot come from? Mainly the factories in India and China. And it's such that the wind patterns dump all that stuff on northern Canada and on the Arctic ice cap. You may have heard in the last 35 years, the Arctic ice cap has shrunk to half of its normal size. But what's probably most responsible for that are not greenhouse gases, but all this soot. And so finding a better way to have these factories work where there's not so much soot production could really help. And incidentally, you say, why India and China? Well, Western Europe, United States, and Canada, our factories emit a fraction of the soot that comes out from the factories in India and China. And so there are ways that we can do but that's one example. And likewise, we're now replacing CFCs because they're damaging the ozone layer with HFCs. What we now know is the HFCs do half the damage of the CFCs, but do enough damage that we shouldn't be using those either. And so again, having a global perspective, let's look at the whole situation. And again, I want to tell you as a research scientist, the vast majority of my colleagues are hyper-specialized. They're really great experts on one narrow subdiscipline. But if you want to get the big picture, you got to get them all together. You need to be reading broadly through the scientific literature. That's one thing we're trying to do at Reasons to Believe, is do that. And by the way, on my Twitter page, I alert you to the latest scientific research papers that are pertinent to the Christian faith. You say, I'm not sure I can read those papers. That's fine. The abstracts give you the bottom line, and the abstracts are always free to read. I give you a link right to the papers. You can read the abstract for yourself. Yes?
Isn't it true to say that the global climate system is by definition a chaotic system, which by definition means you can't attribute causality? How does that therefore play against these assertions that anthropogenic climate change is real through CO2, when by definition it's a chaotic system, so you can't attribute causality in the first place?
Okay, good question. He's making the point that, climatology is a very complex scientific discipline. And how can you trust the conclusions coming out of all these research papers given the complexity of the era. And I'll give you an example. 100 years ago, we had weathermen that could tell you the weather 18 hours into the future. If you asked them to tell you what the weather was going to be like 2 days in the future, they couldn't do it. Realizing how complex weather prediction is, what we basically did in meteorology is we put weather sampling instruments all over the planet. And now we've got satellites that orbit the planet. And so today we can relatively accurately tell you what the weather is going to be like 10 days into the future. Climatology is getting there. We're at the point where we're now getting reasonably accurate computer models that will predict future climate. But how long is it going to be before we have climatology models as good as our weather predicting models? Probably another 100 years. Because that's what it took of weather forecasting. We needed 100 years of good data before we could actually project that far ahead. And so yes, there are still major uncertainties. But again, I'm arguing what we did with weather forecasting, we went interdisciplinary. We need to do the same thing with climatology. And so one of the things we're discovering, for example, there's a lot of focus on carbon dioxide and not that much focus on nitrous oxide or methane or the HFCs. And so looking at all the greenhouse gases and seeing their relative effects, they all have different time constants. That needs to be taken into account because a lot of skeptics have said, you know what, the carbon dioxide warning we're not seeing. Maybe it doesn't exist. Well, we do know that carbon dioxide has a warming effect because we can see it in the deep ice age cores. What you see is that carbon dioxide correlates with global mean temperature literally back to 3 billion years and does it with some precision. However, we don't know exactly what the time constants are. Is there a delay of 20 years? Is there a delay of 40 years? And so that's where research is focusing on now. But it's kind of making your point. This is a complex subject. And I think we need to be encouraged how much progress has happened literally in the last decade, but we got a ways to go. And where you got this kind of complexity, I think you need to be careful about the solutions to the problem. Because if you don't understand the complexities, you can get unintended consequences where you actually make things worse rather than make things better. And so what you'll see in my book coming out in March or April is a chapter on unintended consequences and how before we take legislative action, we better understand the complexities. Otherwise, we could be sorry for the laws that we have passed. I'll go with you first. Go ahead. Whoops.
My wife and I have an air conditioning company, and we took, they had refrigerant 22 that they were using, which was an HCFC, and now they've gone to R410A, which is an HFC.
Right.
And now they're talking about possibly going to another refrigerant, which means everybody's going to have to change their units out again. Do you know at all what kind of refrigerant they're thinking of, moving to after an HFC, which they currently have?
Okay. This gentleman here is into the air conditioning business, and he remembers when we were using CFCs to cool our air, and now that got banned because it was ruining the ozone shield and causing all this ultraviolet radiation come in and ruin our crops. And so there's a worldwide ban on CFCs. And what's replacing the CFCs are HFCs, which is what's in your refrigerators now. They're not quite as efficient as the CFCs, but they don't do as much damage to the ozone shield. And the thinking from the scientists talking about unintended consequences, we assumed the HFCs would do no damage to the ozone shield. We now realize they do damage. It's not trivial, it's significant, not as bad as the CFCs, but it's at about a 40 to 50% level of the CFCs. And so now there's a worldwide ban coming into effect on the use of HFCs. It's going to hit the United States and Canada first. India and China get another 8 years before they got to get rid of this stuff. So yeah, you are going to have to find another refrigerant. And there are refrigerants available, and again, it's kind of like the CFCs. They're not quite as good, but they do a whole lot less damage to the environment. The good news is they've actually come up with some refrigerants that are going to be cheaper than the HFC. So this could actually help your bottom line. So, but again, it's an idea, we should have studied this in more depth before we began passing all these laws, because I think it's causing frustration for people like yourself. Hey, we banned this, and now you're banning my substitute. Are you going to ban my next substitute? What am I going to do with all my employees in my factory? So I sympathize. Yes, go ahead.
Yes, sir. You mentioned that one of the asteroids caused a huge cloud of dust to go into the solar system. Any chance for origin of life studies in that?
Well, there is a lot of talk in origin of life. The question was about, these asteroids hitting the Earth. How does this impact origin of life thinking? One of the new...
Is there maybe microbes that are in that dust or stuff like that?
Well, that does happen. The question was, when an asteroid hits the Earth, what happens to the microbes in the Earth? They get exported. We're worried about our spacecraft landing on Mars and infecting Mars. We really shouldn't worry. We've been infecting Mars for billions of years. Because every time a big asteroid hits the Earth, you get Earth soil being ejected into the solar system. Every ton of Earth soil has got 100 quadrillion microbes in it. And so that's being deposited all over the solar system. Now, the layer isn't that thick. If we're talking about Mars, you're only talking 200 kilograms of Earth soil distributed over every 100 square kilometers of Mars, which means that NASA is going to really have a hard time finding the remains of those Earth microbes on the surface of Mars. A much better bet is to look on the Moon, because the Moon, we're talking 20,000 kilograms for every 100 square kilometers. And therefore, we return to the Moon with a different mission, we should be able to find those microbes. I'm personally excited about that because Earth's geology has destroyed all the fossils of Earth's first life, but the Moon has virtually no geological activity. So we will find the fossils of Earth's first life on the Moon. They're there. We just have to go there and find them. And that, for me, will be a huge breakthrough because atheists have a very different model of what those first microbes will look like compared to us Christian theists. We can literally go to the Moon and determine who got it right, the atheists or the Christian theists. I actually spoke on this at NASA Houston a few years back, saying, we need to go back to the Moon with a different mission. And I says, I think the US taxpayer will be excited about this, because the last time I checked, 100% of US taxpayers were either theists or non-theists. And they should all be excited about figuring out who got it right. Over here.
Yes, could you tell me what science says the accepted age of Earth is, and by what means did they determine that?
Okay, the question is, have scientists come up with a way to determine accurately the age of the Earth, and what are the best techniques for determining the age of the Earth? The answer is yes, they do have tools for accurately determining the age of the Earth. The number is 4.5662 billion years, plus or minus 0.0001 billion. So they actually have it measured to 5 places of the decimal. Now, there's over 20 different ways of getting that date, and they all come up with the same number. So there's a consistency we see amongst the different dating methods, but the one that gives you the highest precision is where you look at the 2 isotopes of uranium in the most ancient material on the Earth and in the solar system, and 1 isotope of thorium. So it's looking at uranium-238, uranium-235, and thorium-232. And those 3 radiometric isotopes decay into 3 different isotopes of lead, lead-208, 207, and 206. And 100% of the lead in the universe comes from the radiometric decay of these heavy radioisotopes. So all the lead comes from those sources. And so you can pick up this ancient material and measure the quantity of lead-208, lead-207, lead-206, the quantity of uranium-238, 235, and thorium-232. You're basically getting 6 independent ways of determining the age of the sample, the fact that you get the same answer for all 6, and the answer is 4.5662, is why scientists have such great confidence on the age of the Earth. We don't have as good a date for the age of the universe. There we only know it to about 3.5 places of the decimal. Still pretty fantastic, but not as good as what we have for the Earth. Okay, I'll pick you in front, then we'll go to you in the back. Yeah.
What do our young Earth creationist friends think of all these models, and how do they try to explain what you've got here?
Okay, how do our young Earth friends respond to all this stuff about thousands of years, millions of years, billions of years? They do recognize that there are scientific difficulties with their interpretation. In fact, what I've seen in all their writings, and I've debated several of them publicly, is that if the laws of physics have not changed, the Earth can't possibly be young, or the universe young. But the way they support their young Earth interpretation, they say that either at the time of the fall of Adam, or at the flood, or more likely at both times, the laws of physics radically change. And when they say radical, they're not kidding. They mean that the radiometric decay rates, for example, speed up by a factor of 1 billion times. But they all also recognize that that's got problems. If you speed up the radiometric decay rates at the time of Noah's flood, what happens to all the potassium that's in your body? That potassium is going to decay into argon. It's going to kill you within microseconds. And they say, well, that's an unsolved problem we have. Well, a solution I recommend is this. Look at the Bible. What does the Bible state about the laws of physics? And if you go to Jeremiah 33, Genesis 3, Revelation 21, Romans 8, the book of Ecclesiastes, those are several passages that declare the laws of physics have been fixed and unchanged since the cosmic creation event. And so you don't need to look at the science. The science does tell you that the laws of physics have never changed. We see the same laws in distant galaxies that we see in our own galaxy and here on planet Earth. But the Bible itself declares there's been no change in the laws of physics. Jeremiah 33, God is complaining about the Jews and says, you change all the time. You're always changing your mind. But I'm a God that never changes. As evidence that I'm a God that never changes, look at the laws that govern the heavens and the earth. As they have never changed, I have never changed. So that's just one of several biblical places you can go that says the laws of physics don't change. The other thing I share with my young Earth friends, it's not enough to read the Bible literally, you have to read it consistently. Just like we've been arguing here, in order to get a handle what's happening with our climate, you need to look at all the scientific disciplines, not just one narrow subdiscipline. Same principle applies to Christianity. We need to look at all 66 books of the Bible, not just one of those 66 books. And so integrating all 66 books, what you discover is the only way to defend biblical inerrancy, at least in my opinion, is that these days of creation in Genesis 1 are 6 consecutive long periods of time, in which case you have no conflict with the established scientific record. And I've found in engaging my young Earth friends, you need to talk about the Bible. Get them, actually get into a Bible discussion. Don't get diverted into the science, but focus on what the Bible says about the age of the earth, and also make the point, this is not a salvation issue. Notice the age of the earth does not show up in any of the creeds of the church, not even the longest creeds, like the Belgic Confession, the Westminster Confession. They're silent on the age of the earth. It's not an essential to Christian faith. And I'm really highly motivated. We need to take the hostility out of this debate. If it's not in the creeds, there's no reason to treat one another in an unchristian way. And always recognize non-Christians watch how we debate one another. They'll know we are Christians by our love for one another, not by our hostility towards one another. Okay, you were next. Yeah, go ahead.
When I read your abstract about what you were going to talk about the 3 darts, I thought one of them has to be the Yucatan asteroid.
Right.
It didn't show up in your 3 darts, so I was wondering
Okay, the question is, why didn't you talk about the other darts? I only talked about 3 darts. And as I said at the very beginning, I was focusing on the darts that God threw at the dartboard of planet Earth that are the most recent. If you go back before 2.5 million years, you discover there was a whole lot of darts that God was throwing at the Earth, and how every one of those darts plays a crucial role in making our existence possible today. The one you mentioned was the dart that was thrown in the Yucatan Peninsula, which happened 66 million years ago. So that's quite a ways back in time. But it was that event that paved the way for the explosion of bird and mammal species, which was crucial to our future existence. It also introduced a change in the chemistry of the Earth that made possible grasses and grains, which is what we need to be able to feed all of our population and all of our animals. Now, if you want to see some details on that, I've written about that particular dart in Improbable Planet. That was released a couple of years ago. It's out there at the table. And we talk about several other darts in that one too. The Permian Triassic event was also generated by a really big dart thrown at the Earth, just the right time, just the right place, just the right composition. I can also share this with you. You know all the gold that you wear on your finger and you use in your electronics? 80% of the gold that's in circulation in human society comes from an asteroid that hit South Africa just outside of Johannesburg. 50% of the nickel that we use in our technology comes from an asteroid that hit just outside of Sudbury, Ontario, not too far from here. And so there are other reasons that we can thank God for being the ultimate darts player. But I was just giving you the highlights. Okay, I don't know who's next. I've been ignoring this side. Let me go back over here, and I'll get to you next. Okay.
The consensus on the age of the universe for a long time has been that it's been a little bit less than 15 billion years old. There have been recent reports that there's some evidence that it may be about a billion years less.
Yes. Okay, the question was this. For the last several years, you got astronomers saying that we've got measurements that consistently tell us that the universe is 13.8 billion years, but there was a report several months ago that was saying, hey, it looks like we were a billion years off. And it's basically a new study done of Cepheid variable stars in the most nearby galaxies, especially the Large Magellanic Cloud, that indicated that the expansion rate of the universe was a little more rapid than what we had thought in the past. Now, if you read the paper, the authors of the paper, and by the way, 2 of those authors went to graduate school with me at the University of Toronto, so I know of them, they made a caveat at the end of the paper saying, notice this is a measurement based on what we see in the nearby universe. We need to see what's going on in the more distant universe. And basically, they were making a case. Maybe the universe expands more slowly in its early history than it does in its more recent history. And actually, that's established astrophysics. Dark energy basically predicts that the universe will expand more rapidly as it gets older and older, particularly in the last half of the history of the universe. And so basically, they're saying maybe dark energy is more complicated than what we thought, not driven by one constant, but by 2 constants. However, and by the way, there's our article. I've written 2 blog articles on our website that actually deal with your question in detail. So this is why I'm trying to be brief here. And what they've done is they've used a second technique for measuring the nearby expansion rate of the universe. Instead of Cepheid variable stars, they're using what astronomers now agree is a much more reliable standard candle, which are what are called tip-of-the-red giant branch stars. I won't go into the technical details, but the answer is it was more consistent with the 13.8 billion than, say, the 12.8 billion. And the point I make on my articles is that these methods that are based on Cepheid variable stars and to a lesser degree on tip-of-the-red giant branch stars have error bars. And the error bars are not small. And therefore, we shouldn't be disturbed that they're slightly discordant with the much better error, smaller error bars, we get from maps of the cosmic background radiation. There you get quite tiny error bars, but again, when you're looking at the microwave background radiation maps, you're measuring the state of the universe when it was only 380,000 years old. And all Big Bang creation models predict that's a time when the universe will expand at a slower rate. So we do expect to get a smaller value for the expansion rate based on these cosmic background radiation maps than we do of. But the real goal of these astronomers is to determine, are we looking at one constant governing dark energy or two constants? That debate is not yet settled. And incidentally, we're only talking a few percent discrepancy. But the 9% discrepancy that got all the headlines about a year ago, that 9% has now been reduced to less than 3%. And it's basically tilting the measurements back to the 13.8 billion years. So cosmology is now a more precision science than it was a year ago. Okay, you were next. And by the way, this has got to be the last question because I'm supposed to let you go to lunch.
My perspective might be a little unique. I'm an investigate this. The first thing I wanted to say is I haven't seen any connective tissue from the science aspects to a creator God or a Christian God, but that's not what my question is. When you put up the display about the supernova, the only one that I'm actually familiar with is the 1054 supernova that was
Right.
seen by the Chinese astronomers. The numbers that were there are giving me numbers for not when the supernova happened, but when the supernova was observed by us.
Right.
Otherwise, the last four notations on that, we would not have seen yet.
Right.
What the piece that I am missing is, are we talking about supernovas and the radiation and how the mutations affect the Earth? And if not, what are the dynamics and what are the
Right. Okay. His question is about the supernova slides I was showing, and wondering, okay, are we talking about when those supernovas erupted or when the radiation reached us here on Earth? And it's the latter. It's when the radiation reached us here at Earth. Because, for example, the supernova that exploded in 10,054, that star that's went supernova is 7,000 light years away. And so it actually erupted 7,000 years before 1054 AD. But we're talking about its impact on life here on Earth. So the significant point is, when did the radiation reach Earth? And you also had a follow-up question, what does that radiation do? Well, it's predominantly synchrotron radiation. And yes, it does damage the DNA of life. And so it's going to raise the cancer rate amongst humans. Its main effect, though, is that it's the hard radiation from the supernova basically pokes a hole in the ozone shield and allows a lot more hard ultraviolet radiation from the sun to come through, and that has a rather damaging impact on photosynthetic activity. So that's the biggest negative impact from these close-by supernova eruptions. It basically drops the photosynthetic efficiency of our food crops, and so you wind up with a lot less food being able to be produced. And it's one reason, for example, the human population 20,000, 30,000 years ago wasn't that large. They just simply didn't have the capacity to grow the quantity of food that we can grow today. And of course, they're also dealing with climate instability that we don't have to deal with today. I appreciated your first comment too. I really didn't strongly link the scientific evidence with the evidence for the God of the Bible. That really wasn't my purpose. My purpose was to give you an update on the fine-tuning evidence. And if you look at that in detail, that's where you get the link. In fact, what you'll see in my books is I try to make the point that the fine-tuning evidence not only points to a being beyond the universe that intelligently designed the universe, but we can actually identify whether it's the God of Hinduism, the God of Islam, the God of Christianity. And I'm basically making the point, we got such a wealth of fine-tuning evidence today, we can actually identify which of these different gods amongst the religions of the world is behind it all. But that's why we got books here. Okay, with that, I'm going to let you all go to lunch. Thank you.
providing an integrated approach to theology, philosophy, and apologetics that will equip you to proclaim the gospel, engage the culture, and defend the truth. That's SES.